Hello, this video is about heat engine example. One of the students, I believe Daniel, asked this question on the discussion board. Let's take a look at it. It said an automobile engine produced that much shaft power and with a thermal efficiency of 30%. And fuel provides this much heating value as it burns. So the way we approach this problem, we're going to draw our heat engine. So we're going to draw HE, and we know this is going to be the hot reservoir, and this will be lower reservoir. And the heat engine will convert the heat coming to work out. That's going to be the shaft work, right? That's going to be the workout. Okay. And also inevitably we know there's going to be heat leaking out because it's not 100% efficiency. So to let's go ahead and label what we have here. The produced 139 shaft work. So that's going to be 103.7 kilowatt. I'm going to use kilowatt. And efficiency is 30, so that's going to be the heat engine is 30%. Now let's go ahead and review the heat engine efficiency. It's desired over required. Of course we desire more workout, right? The turbine workout, and absolutely required is a QA. Okay, we can add a dot to both of them. So for power. So now let's think about what else. And this is how much it burns, and that's going to be the heating value. So let's look at this heat engine efficiency. Do we know workout? We do. It's 103.7 kilowatt. So we can find how much the heat, how much heat coming, right? So then go ahead, solve QA. So 103.7 divided by, let me go ahead, 103.7 divided by 30%. That will give us a value of 345.6. Repeating, that's going to be kilowatt. That's the heat coming. However, they ask the heat rejection. So basically, they want you to find a Q out. Now we know for this cycle, the energy conservation. Let's look at the cycle. Whatever coming in, we have QN here. And whatever come out, we have heat leaking out because it's not 100% from heat convert to workout. Another going out is this one, workout. All right, so that's another one we review. We can find the Q out right here since we know the QA. And we also know how much work has been produced. So QA is 345.6 from the first step. Then minus the workout is 103.7 kilowatt. So we'll minus 103.7. Then we will have this value, 241.96. Repeating, that's kilowatt. That's heat leaking out, rejected from this engine. Okay. Yeah, and then the last thing they want us to know is rate of fuel consumption. How many kilogram per second, right? That's good information to know because they told us it is 35,000 kilojoule per kilogram. That means every kilogram of fuel we burn, it produces 35,000 kilojoule. Now that's related to this heat coming, right? So we have to come back to thinking about this. We know QN here is we know that is 345.6 kilowatt. That means kilojoule per second. Then we have to use our dimension homogeneity to help us figure this out. We want to get this value. So what do we need to do? I'm going to use a different color. So I'm going to have second right here, if I use second right here, then I'm going to get divided by kilogram, right? This is something I want to solve because I can get rid of my second, then I will get my desirable unit as kilojoule per kilogram. That's our heating value right here. That's our every kilogram of burn, it's going to produce 35,000 kilojoule. So we need to solve this one. And this one is exactly the reciprocal of what they're asking. It's every second is going to how much kilogram of fuel come in. That's basically your mass flow rate. So how do we go ahead and solve it? We can see, all right, it's basically we go ahead solve this. We can do this. There are many different ways to solve it, and this can be just 345.6 kilojoule per second divided by 35,000 kilojoule per kilogram. In that situation, you will I'm actually solved a different way. Okay, so here I made a mistake. This is going to be kilogram per second. Okay, so if we're solving this mass flow rate, I'm going to use this kilojoule per second divided by kilojoule per kilogram. Why do we do that? Because kilogram canceled out, I will get our desirable unit of kilogram per second. That's what we wanted, right? If we use 35,000 divided by 345.6, that would be in second per kilogram, right? But we want to know kilogram per second, right? So let's go ahead and solve that one. 345.6 divided by 35,000, that would give us very small value here. I will have 0.009874 kilogram per second. Okay, so that's what I have for this one. All right. Okay, that's the webwork heat engine. All right, see you next time. Bye.